All right. You're welcome to today's class. Today we want to look at two's complement. What is two's complement? Two's complement is a method that bends negative number into a finite binary universe without breaking addition. We are looking at mathematics, right? And I told you what we are doing presently. We are still building the binary. We started from voltage. From voltage, we were able to derive binary, which is 0 and 1. And then from the 0 and 1, we are seeing patterns. And then we are putting these patterns together to derive meanings. So we have been looking at positive number all along. Now we want to look at how the computer represents negative numbers. And that is what we are going to see using what? Two's complement. So I have defined two's complement for you, that it is a method that bends negative number into a finite binary universe without breaking addition. So when I say 7 plus 1 equals to what? Minus 8, you will jump and say, what is that? That is not correct. That is a wrong mathematics. But it is not wrong as far as the computer system is concerned. This is correct. So that is what I want to show you in today's class. Let's begin. All right. So if you are still looking at 4-bit, right? 2 raised power 4 equals to what? 16 pattern, right? Let's assume we are having a community. And in this community, we have 16 houses. And then, so we have something like this, right? 16 houses. But we want half to be what? Positive. And the other half to be what? Negative. The concept. So we'll divide this into 2. So starting from 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and then we have 7, right? So we have this. And this is 4-bit, representing 16 pattern, 0 to what? To 15. So this will be what? 8, right? 8. Now this will be 9, this will be 10, this will be 11, this will be 12, this will be 13, this will be 14, and then this will be what? 15. So 0 to what? 15. But we want this part to be what? Positive, and this part to be what? Negative. So definitely, if that is how we want it, so this will be what? Minus 8. This will be what? Minus 7. This will be what? Minus 6. This will be minus 5. This will be what? Minus 4, minus 3, minus 2, and then minus 1. So, if we are having a constant universe like this, 0 to 16, it means that a negative number is simply a number that when added to its positive equivalent, you are going to have 0. And I have told you, 0 does not mean nothing. This actually represents wholeness. This actually represents unity. Right? So what we are saying is, when you add a negative number to its positive equivalent, the answer should be what? 0. So that is what this is representing. So from 0 back to minus 1. So from minus 1 now we are getting 0. Right? So that was why I said that mathematics, which is what? 7 plus 1 equals to what? Minus 8. So 0 plus 1 will give you 1. 1 plus 1 will give you 2. 2 plus 1 will give you 3. 3 plus 1 will give you 4. 4 plus 1 will give you 5. 5 plus 1 will give you 6. 6 plus 1 will give you 7. 7 plus 1 will give you minus 8. So it means in the pattern representation, we are having 0, 0, 0, 0, right? Then we have 0, 0, 0, 1. Then I told you this will continue up to 8. this will be 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7, right? 0, 1, 1, 1. Now, if you look at this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and then this is 7. So you can see this is 7. Now 8 will be what? 1, 0, 0, 0. This is 8. But since we are representing both positive and negative, it means that we are taking the most significant bit, which is the last bit, as the what? As the sign representation. So this part, this bit is the sign, meaning the 0 is what? Is negative. Right? The 0 is positive, sorry. The 0 is positive. This 0 what? Represent positive. Now, the 1 will represent negative. Right? So, this is 1, this is 0, this is 1, up to 7. So, all these are what? Positive number. Then you start the 8, which is what? 1, 0, 0. So, the 1 here tells you that this is what? Minus. So, this 1 is signifying minus. So, that will be what? Minus 8. That's why we are getting minus 8. So, we have 1, 0, 0, 1. So, this is what? This will be what? Will be 9. But representing it is what? Minus 7. Now, how did we arrive at it being this? What we are saying is that for this system to remain balanced, when you add the negative equivalent of a number to that number, it should give us 0. Isn't that so? All right. So let's check it out. If 7 is 0, 1, 1, 1, what number are we going to add to this to give us what? 0. So that would be 0, 1, 1, 1 plus x equals to what? 0. So what would this one be? That is what we are looking for. So it means we are looking for a number, and that number must not be outside of this range. So we are looking for a number that when we add it to this number, it will give us this one as 0. So what will we do? Two's complement is saying flip this number and add 1 to it. So if we flip this one, that will give us 1, 0, 0, 0. That is, flip every number. So this one will become 0. This one will become 0. This one will become 0. And this one will become 1. So let's add this to this and see if we are going to get 0. So if we do 0, 1, 1, 1, and then we do 1, 0, 0, 0, that will be what? 1, 1, 1, and 1. So this is giving us what? 15. But what we are looking for is what? 0. So which means this one is giving us what? 1. Which is, this one is negative. So that will give us minus 1. But what we want is to give us 0, which means the system is complete whole. So when we flip this and we are getting this, then we add 1 to it. So that will be what? 1. Now let's add 0, 1, 1, 1 and 1, 0, 0, 1 together. So this plus this will give us 2. And you know you cannot write 2 in binary. So you put 0, you will carry 1. This plus this will give us 1. Plus that one you carried is 2. I know you cannot write 2. So you put 0, you carry 1. 1 plus 0 will give us 1. Plus that one you carried, that will give us 2. You know you cannot write 2. So you put 0, you carry 1. So this plus this will give us 1. Plus that one, that is 2. You know you cannot write 2. So you put 0. And you carry what? 1. But remember, we are using a 4-bit system. So we are only going to deal with these 4 bits. And we'll discard this guy. So if we are dealing with this 4 bit, this is 0, 0, 0, 0. So that is equals to what? 0, which is the starting point. So it means we've gotten what we wanted. Right? So if that is the case, we now check inside this our drawing. Right? We have 3, and then we have 4. So inside this our drawing, when we check, what number is equivalent to what? 1001. That number is what? 9. So that 9 is what? Minus 7. You can see. So 9 is the number that when you add to 7 will give us 0. So that is minus 7. So 7 plus minus 7 will give us 0, right? So minus 7 in this 4-bit number system is what? 9. So that was why 7 plus 1 equals to what? Minus 8. So this is the concept of 2's complement. You simply flip the number and then add 1 to it. If you add it to the original number, it will give you what? 0. So this works because we are just representing mathematics. Minus x equals to what? 2 raised power n minus what? X. So this is the mathematics we are representing. So if I'm saying 7, if I'm looking for the negative value of 7, that when added to this will give me 0, right? All I need to do is minus x equals to what? 2 raised power. We are looking at 4-bit system. 2 raised power 4 minus 7. So 2 raised power 4 is what? 16. 16 minus 7 will give us what? 9. So minus x is equals to what? 9, which means minus 7. So using this formula, I can equally look for what? For the number that when added to 5 will give me 0. That is, 5 minus 5 will give me what? 5 plus minus 5 will give me what? 0, right? So using this equation, all I need to do is, we are looking at 4 bits. So minus x equals to 2 raised power 4 minus 5. So this is what? 2 raised power 4 is what? 16. 16 minus 5 will give me what? 11. Now, if you trace it to this place, this is 11, right? 11 is what? Minus 5. So you can see. So 11. So when I find 11 in that number system and I add it to whatever number is, I should get 0. So that is what 2's complement does. So 2's complement helps us to solve this problem. Flip the digit, add 1 to it, and then you will get your 2's complement. So our definition of 2's complement is that it is a method that bends negative number into a finite binary universe without breaking addition. Right? So that is it. Flip the bit, add 1 to it. That is 2 complement. So that is what I want to show you in this class. And all these things that I'm showing you, you will begin to see the practical application as we move on into the realm of mathematics. So don't forget, we are doing mathematics in relation to machine. So don't forget to like and don't forget to subscribe if you have not done so. So till we see in the next class. Bye-bye.